you will have a system somewhere you can work on. You can close your systems and just listen to me. Yes, plants are making more sound than us. Okay, good morning. A small topic, system on chip. Because of the VLSI inventions of or advanced technology in VLSI, there are so many merits that has come up for the hardware segment, which make us to work closely and build the smart devices. So one of the major component in that segment is the system on chip. Today you won't find any device, smart device, or smart appliance, or smart equipment, smart meters, where there is no SOC. So SOC is there in almost all the fields, for small children toys to the complex the robotic applications. The reason is you need to integrate. I think one of or most of us experience when you are the engineering students while you doing it, the kids are very big and you need to have so many components that you need to play and keep it in the integration to develop in circuit. And because today you want these devices to be battery operated only and as compact as possible and as low weight as possible, then LSI technologies helps to achieve that direction. Yes, that I just was attended a conference 8 years ago, an international conference on VLSI design, which is one of the most popular uh, international conference, where there those days, I mean, I'm remembering the conference keynote talk where you have a transistor. Transistor size is 2 electrons. Assume that every transistor has three pins, three terminals where emitter, collector, and base, which we have studied, and feel and touch and connect and solder it, which we may have done it. But today, if you look into those electronics or the transistor or basic logic gates, and each transistor is made up of few electrons. That was the technology which they were talking about it. But you have at present the chips which we are using. We have in real products the few atoms. So atom size is even 10 to the power of -8 meters. Looking into that size, how do you think that they are interconnected? How do you do that? They are the power consumption. How do you take care about the placement, the scaling, multi layers that are coming up, and it's all possible with the ED tools that are made available to the VLSI segment. And as a result, we are all witness to see work with those tiny devices, and one of that is the mobile segment. This talk is primarily focused about in order to make a smart devices or the smart equipment or smart phones, what is the role of system on chip? How is going to help us, and why we need to study the SOC? Because if you look into the mobile, even if you see the smartphone what we are building, Raspberry Pi is coming up with a Broadcom SoC. Most of the components is taken inside the SoC. Had it been outside, probably you won't be. I won't be able to do the training for all of you in a week days. Rather, I may need to take it a month time because to talk about each of the component will take you interfacing all of them and programming, connectivity, testing is really a complex task, time consuming. In a nutshell, an SOC is a system on chip. We assume that if I want to take a simple example, a practical example, if I want to teach you, being you are at your own destinations, how difficult to me. I need to travel each and every institute and take the time and spend you and make you training and make you aware of what I'm trying to do so. That is a methodology where a traditional methodology is being used. Now assume that I want to integrate or automate certain process of that. I send a proposal or invitation to all of the institutions interested people, please come here at the NITTR. Let's meet in the CSA department and host you a 1 week training program. So I'm spending a 1 week in a small room like this and training you in a short span of time of 5 days what I need intended to deliver. If the same thing I need to deliver, being you are all different places, the size at which I need to travel is more, the time that I need to spend is more, the cost that I need to spend is more. So because everything is expensive, time consuming, more resources. In similar manner, if all the electronic components kept it away, power consumption goes high, your size goes high, reliability goes down, and your time to develop a product goes high, and all leads to a unable to meet the time to market constraints. So what an SOC is going to do, rather having the distributed system away from the CPU and connected with different incompatible tools and processors or buses, all these problems to sort out, you have a method by which bringing heterogeneous, homogeneous, not only processors but also different kind of electronic components together into a single piece of silicon, we call it as a system on chip. If I bring it like everybody bringing from different places into the NITTR department, is that is what the system on chip, rather having a distributed faculty or distributed components of computers brought together and made in a single brick of silicon, and that is several folds cheaper than individual components. So it is a, I think most of you know the microcontroller. We talk about microcontroller is a computer on a chip. So you have a computer on a single chip. What does it mean? You have a processor, you have a memory, you have I/O peripherals, and many more components required to build a computer. But imagine an SoC is a many computers in a single chip. And microcontroller is a single computer on a chip, but an SoC is a many computers on a single chip. What does it leads to us? If you see, in the case of personal computers, for them, whenever I teach embedded systems, there are 30 to 40 computers working together as a subsystems in a complex system of desktop computer. For example, if you see the keyboard, you have a dedicated computer keyboard where maybe you have 8086 or 8051 or 8085 microcontroller or processor being there, have its own memory. Whatever you keep pressing, its function is generate the scan code and send to your processor. This is a dedicated computer. Similarly, your hard disk drive, floppy disk drive, your Ethernet card, and likewise, if you think, then Bluetooth controller, Wi-Fi, Ethernet. So every small subset, you have a dedicated computer working as a subsystem along with your main system. So each one is a dedicated computer. Now, and that's the reason you need a bigger space, which you are witnessing all of us. In order to reduce the power consumption and size in a smartphone segment, we need to brought it down. And when I need to do that, what is the technology behind it? It is one of the technologies, the system on chip. Let us have all those computers in a single chip. So we'll show you in a couple of minutes later how these systems are there and why they are there with respect to the smartphone segment. So you please understand in a simple sense, an SOC is nothing but system on a chip. When I say system, there are so many subsystems. Each subsystem is a one computing system. So that means there are so many processors, different kinds of memories, different kinds of input-output peripherals. It's the many computers sitting in a single brick of silicon together made us task to develop your products very fast. Had this SOCs is not built, you won't be able to develop any smart devices or smart meters or smart equipment. Take individual components. It's as same as that. If you are not able to bring, or the NITTT are not able to bring all of you to this particular place, it's quite difficult for me to come on every institute to deliver the same training. So, SOC makes simpler your design, faster, better, reliable, and even cheaper. Okay? In order to achieve the time to market constraints. To see in the entire course of maybe half an hour, 45 minutes, how the SOCs are going to help for both mobile segment and other segment, and which SOCs are currently being used in mobile development. And we take the case study of the Raspberry Pi because we are going to use building the mobile phone by using the Broadcom SOC. We will more details on that. So taking into the development, taking about the SOC as a given the definition, and what are the basic building blocks of an SOC. Any SOC you find couple of heterogeneous or homogeneous processors. For example, I may have a ARM7 itself 3 to 4 processor setting, or I may have a ARM microcontroller M3 or M4, maybe 4 or 5 different numbers for different purpose. I may have an application processor. I may have a GPU, graphics processing unit. I may have a DSP, digital signal processor. I may have a co-processor. I have image processor. I may have so many number of different processors doing for dedicated tasks. All are within a single brick of silicon. Apart from that, in every SOC, you will find at least couple of memory components. One is couple of processors, various kinds of processors, and second components are along with the processors, you may find some graphics processors, some DSP processor or image processor or some core processor or some map processors. This is the processor segment. You may use 64-bit to 8-bit processors in a single SOC. There may be certain processors 64-bit in length, certain 32-bit, certain 8-bit or 16-bit depending upon the need of your application. Then coming to the memories. So no SOC is available in general without memory component on SOC, because when I say this is a multiple computers on a single chip, so every computer needs a memory. Then you may have static RAM, dynamic RAM, or you may have L1 cache, L2 cache. Apart from that, you may have some flash memory on chip, maybe dynamic. You may find this basically NOR flash, especially in the SOCs. In some cases, you may have some bootloader, boot ROM in order to take care of the firmware of the SOC. So you find, for security other reasons, the key version of the boot ROM. So this is the memory segment. Then if you look into the other components of, you may have some kind of peripherals. I may have I2C communication peripheral. I may have SPI peripheral. I may have UARTs, I may have USB. There have been so many HDMI interfaces, so many communication ports that has to be there within the SoC so that you can connect IO devices directly. Add these things to be interfaced separately, you need to spend months of time to develop even a small equipment. So SoC is cutting down our time for the development of this. So see this some of the SoC. Look at generic components, how an SoC consists of. So as I mentioned that you may have a graphics processor or DSP, then you may have an application processor or embedded software RTOS support available with the SoC. SoC, when I made an SoC for example, and there should be a support for an operating system. So there is a firmware and support of real-time operating systems or mobile operating systems already provided within the SoC. If I build an SoC completely and tomorrow I build a new OS without considering that SoC, then there is no support of SoC with that particular OS. So most of the vendors they has to work together. The OS vendors, the SoC vendors, and the tool developers has to work as a team so that one will support for other or other will support for the other components. Then you have a configurable hardware because of some security reasons or some communications. So you will also configure certain IO peripherals. So there are different configuration peripherals. And some other components, into signal. JTAG is used for certain on-chip debugging because when you develop an applications, you need to test in a real environment. So I may be ported onto the SoC and I want to test it. How is it going to work? Where is the bug? So we use the JTAG, stands for Joint Test Action Group, which is one of the popular methodologies to test an application on the device or on the fly. Then you need to have different communication interfaces, audio, video, camera, then IO filters like USB, HDMI, cables for any additional interfaces that you need to make it. So all of them is available in a single kit. Assuming that the mobiles which you have as smartphones, you will find around 200 to 300 pins with a size of 2 centimeters length, 2 centimeters width, maybe height of 5 mm. Assume that around 5 crores of transistors, 5 to 10 crores of transistors within that silicon, and each one may be taking few atom size, even less than the atom size. You have as I mentioned that Intel Quark SoC has 50 nanometers technology, which assuming that the transistor size is 50 nanometers. So with that size, you are trying to build all those systems in a single silicon, and that you just place it in a PCB, and then you just connect only. You need to connect only I/O devices out of that. So that is the simplest way, and that's the reason why you are witnessing every month or every week a new mobile device. Reason the SOCs might be same, or once they design an SOC, what are they going to change? The operating systems may change, the peripherals that are they supporting to change, then the development environment, the languages are going to change. So if you see that Qualcomm SOCs are being used by the Microsoft or Nokia or Micromax, any mobile vendor you name it, they are using, but they are different in nature, different features. And within the SOCs, there are wide range, and they choose from low cost to high cost and different variants that has quad core to dual core or single core SOCs. So this is a common generic architecture of an SOC so that your hardware tasks become simple. Today, you don't need to focus much on that sense. Once you choose an SOC, every hardware is available. You need to take up what is the right interface, and then you need to configure the mostly software time, and that makes you faster development and faster release of your products. So if you look into this, the common characteristics of an SOC. SOCs are basically smaller in size, and that is why we use it in the all handheld devices. Not only handheld devices, in even the consumer electronics, because of size and performance. Because they are high performance, they are available in hardcore mobiles. You may be finding with ARM and 8 cores. Each core runs on 1 GHz, so you could say that 8 GHz speed not have a desktop processor with octa-core running in each one of that. So you see the processing speed. Then you have the power consumption is few milliwatts in some cases, few milliwatts to few watts, not more than one digit. That's the power consumption within SOCs. When you talk about your desktop, as I mentioned yesterday, is few watts. Then the space, as I mentioned already, the space requirements is so much small, so you can have the complex devices in a small size as a wristwatch or in the small handy hand palm tops, which have a more uh, capabilities than your servers. And the memory very good, and you don't find that the applications are running lower speed because you have enough memory and have the mixed signal, analog and digital signals are already mixed, including the RF. Then and it leads to the further high reliability, low cost, low power consumption. All these characteristics leads to use SOCs for building the smarter devices. Now, where do we use these SOCs? We not only use in the mobile segment, but we also use in the communications for your routers, for your digital cellular phones, networking, and smartphones. The computers are also small. We won't use the complex SOCs, but there is a range of SOCs. You may be using rather having the two computers dedicated, you can combine it and have even you see the sizes of the desktops also reducing just because of SOCs being used to replace the some of the computing components. And then in consumer electronics and gaming, even including your digital TVs, there are so much of SOCs being used. In set-top boxes, you have an SOC. And everywhere today you will find SOC because if I want to make the components that are available in an SOC, individual components, if I want to buy, it costs you 10 times more than the cost of the SOC. If I want to build, let's say, an SOC, one hand, and the other hand, all the components which are available on the SOC, at least it will cost you 10 times more cost if you buy individual components. The reason is their silicon, their design, and they require a lot many copper because the silicon cost primarily depends on when you manufacture in huge numbers. Copper, the metal that is carrying our is the cost more cost element. Sometimes you use the copper, you use the gold, or you use the platinum, or the combinations because of the interconnections, or because of the tiny components which you need to connect has to have a reliability, stability for power and other power dissipation. And so the costliest component in silicon chip is basically the conducting part, the buses. Okay, so when you take a long distance, this is really cost you more. So when you reduce the size, the conducting path can further reduced, and that results in further power consumption, and so you reduce the power requirement. So keeping in that, you have a lot of merits in the SOCs, smaller space, power consumption, cost, and of course it even provides for security and and fast execution, of course, because of the integration of the components, and it leads to the more reliability and performance. So this is the merits that why we get, why we need to use. I'm sure that in future you won't see this. You will only see one brick of silicon. Everything you connect it outside. Okay, so it's like electrical cable. You connect it any IO peripheral there, it works out. So we don't need internally all communication ports, all computing ports, or RF signals and memory segments, computing segments, everything you will have in a single brick. And then what we all need is you just plug in play, connect whichever the IO device you want. All is basically going to be in the next. So going to this the challenges, of course, because when you need to do this SOC design, there are a lot of challenges, but I'm sure that this course we don't be addressing those challenges. So, but otherwise, they are it's not as easy as I said, but there are several challenges that you need to face while designing these SOCs because any RF component requires more power, or some component this creates a lot of heat. You cannot bring into SOC. Let's say I want to have a power transistor, but you cannot bring it to the SOC because of the more power dissipation. And there is heterogeneous processors, and one needs to communicate other. It has to spend different means, and the buses, bandwidths, and the memory controllers all has to be designed in relation with other components. It's very complicated task. It's very difficult, and one SOC design takes you million man hours by the industry because they spend a lot of time. But once they have an IP already being made, they could reuse it and try to build at the faster. Tools make them to faster design. Just one important thing, which is purely my perception how SOCs will be there. So we broadly classify the SOCs for mobile segment and SOCs for personal computing. So SOCs for mobile, we have three major role players at present. Intel Atom-based SOCs are available, and Qualcomm-based Snapdragon series of SOCs are available. And at present, the most of the processors, the mobile segment consumes the SOCs made by the Qualcomm. They have SOCs from 400, 800, 600 series, and within the 400 again they have different series of SOCs based on their features. But at present, the highest unit of SOC you will find is Snapdragon 800 series. Then, as I mentioned, that TI has a roadmap of OMAP SOCs, open mobile, I think open multimedia platform. That is an SOC. They have OMAP 2, and I guess OMAP 5 also. I'm not sure roadmap 5, but they have the design, but then it's not getting into the mobile segment. But these mobile, yeah, now they are using for the industrial applications rather mobile applications. So this is from TI, this is from Qualcomm and the Intel. So based on Intel, Atom SOCs are available, Qualcomm Snapdragon, and TI's roadmap series of SOCs being used for the mobile segment. I think three of these vendors will consume, I guess, 98 to 98% of SOCs that are the in mobile devices. Of course, then coming to the SOCs for pervasive computing means all other smart equipment, consumer electronics which we need. Because in these cases, there is not much requirement of communication. Rather, there may be analog signal or digital processing, or it may be some computation is the main intention here. But here, main intention along with the graphics, multimedia, and communication interface more stress is being given in there. So here is the Broadcom SOCs, which are one of the popular. There may be many more SOCs we got into the main category. But as far as which we are doing that, I will review research orientation coordinate with those classes only. So one of the Broadcom SOC 2835 is Raspberry Pi uses Pi 1, Pi 1. All the models uses the Raspberry Pi. Broadcom 2835 SOC, and then the Intel Quark SOC. We discuss about these things today. So this the SOC by Intel Atom. Looking into this yesterday, we were talking about the various memories. For example, you have a dual core Atom,
It supports graphics processor for both 2D and 3D graphics. There is a video decoder. There is image processor. Then you have a various bridges. Then you have the L2 cache of 512 KB, L2 cache of 512 KB, then DDR RAM. Then you have a here I/O peripherals for UART, SCI, HDMI, then micro SD card, then DDR RAM to support, and the other side also the same. And USB. So looking into this, what we understand, depending upon the need of application, generic components exist in every SoC, but the specifications of each one is varies. Okay, so they may have one DSP or two DSP of various speeds. They may have cache sizes in the variants, one level or two level. They may have memories of various sizes, or the various I/O ports, I/O components like UART, I2C, USB, or Bluetooth, HDMI, Wi-Fi interfaces as per the requirements of the particular SoC. But generically, the components are there. What we discussed, uh, generic components in a specific case of 2760 SoC, that series SoC of the Intel. Now this is Snapdragon 4 S4. Uh, the one of the SoC here is dual core type CPU being used. It is similar to the ARM, but it's modified with little enhanced instruction set. You have here you see L1 cache for this, L1 cache for ARM and L2 cache. Okay. And then you have a Arduino GPU graphics processing unit. Then there is LTE modem for various communications equipment. Two DSPs. The DSP of Snapdragon or Qualcomm's is called hexagonal DSP because the DSP architecture is so powerful for them, and it has a high floating point operations. Lot many features in hexagonal DSP. We are not going to discuss. This you have not only two, you have even it varies depending upon the case. So why we need two or three? Because whenever you use the camera, you may have a dual front camera and back camera. You may require two DSPs. Okay. If in some cases in a signal processing you are doing it, you may have more. So looking into that, this SOC is not a one computer, rather many computers. For example, this is an application processor. It works independently. It works independently. And many more processors for communication segment do have it works everyone independently. So looking into the next one, here I would like to show you a little more details. See here, this is a 4 series have a ARM Cortex A9 dual core, okay, as an application processor. But look into this ARM Cortex M3 two numbers. Look here, you also find here Bluetooth, Wi-Fi, FM radio, GPS. For every one of these, you need a dedicated processor to be used. It could be M0 or M3 or M4. So at least in this SoC, you will find several number of ARM processors, ranging from M0 to M4. And this is an application. Whenever there is an M, that is for embedded segment, that's basically microcontrollers. When I say A, it's basically an application processor. So when I say microcontroller, you will say that this is a computer on a chip. Isn't it? So there are many computers in that sense, and there are many more processors. And each of them, you will see somebody was asking like NAND flash and NOR flash. You have both. You have DDR2 RAMs, then have a data port for this, then flash controller, RAM controller, even these controllers are again processors. The flash controller is a dedicated processor, RAM controller is a dedicated processor, a cache controller, a memory controller, the power optimization, everything. Anything you are interfacing it, you cannot interface directly, you have a dedicated controller to do so. And that further is a subsystem which has a processor. So assume that in a single SoC, how many processors you have, and they are heterogeneous in nature. Their speeds are different, their power consumptions are different, and you want to optimize the power. There is a power control dedicated processor, and, and that's responsible to manage the power for each of them. And then there is a bus controller because you cannot have a single bus. It is like a road. You cannot have the for entire city like Chandigarh one road. You may have different roads, but different widths, different rules. Similarly, here to take the data in and out, you have different bus widths, and that has to be managed. Again, you need a bus controller. That is again a processor. So then we look into that with various I2 interfaces, per script modulation PDM. Then you may have your the USB. Here also one I2S. Okay. Then usually other interfaces you will find the touch screen interface. So every interfaces are supported. What else you need? You can directly connect in HDMI or USB or any other means, all are within SOC. Or in some cases, you can take it outside and interface it. Look at if this is not available in the brick of silicon, you try to do this, your task has become very, very complicated. That is the power of SOCs, and that's the reason why you are able to get every week after a week new mobile device with new features. Okay, so our case which we are doing in Raspberry Pi, this is a basic SOC for Raspberry Pi, Pi 1. Pi 1, you have ARM 11 processor which works around 700 megahertz speed. Okay, there is one core only. This is not even dual core, so one single core ARM 11 processor. Then of course you have a some debug interface for JTAG. Then there is some core processor. Then you have some memory interface, cache memory interface. Then memory management module. This is the AMPA bus interface. So this is basically AMPA stands for Advanced Microcontroller Bus Interface. So this has so many buses for high performance bus, high peripheral bus. Then the bus controller will help you to provide the required bandwidth and data transfer from in and around each peripheral. So the basic architecture of this you could see, you have an ARM application processor. Then there are a couple of core processors, and of course there is a memory a controller and the bus controller that takes care of things. But there is not individual components are being shown in this diagram. We'll show you individual components and other interfaces that are there. But as compared to Pi 2, which we are using in all our boards, it's similar architecture, but it has a chip is a Broadcom 8236. That is the Pi 1 is 8235 and Pi 2 is 8236. And you see this is a quad core ARM Cortex A7, and this will run with 900 megahertz. So 900 into 4, you see with the 3.6 gigahertz speed. Okay, so that is the speed of processor which you are using. Now you have a GPU that supports multimedia and flow processor and supports the 3D and 3D graphics. And you have a DMA interface and 1 GB of RAM, and there is a micro SD card support, and of course there are so many other peripherals on board available. I think we don't need to discuss about much on this, which we are not going to use here, but only discuss one of popular SOC which you could use for learning easily, and Intel supports this on Intel use. You can just write Intel education code probably you can share have tools available for testing and application development. Even we build our smartphone even with the Intel Gen 2. Rather replacing the Raspberry Pi, we have also built the smartphone by using the Gen 2. This is basically this Pentium 2 processor. Now is available between the cost of one less than I think $7 to $8. SOC cost about it. But an entire board, if you need to buy, you may need to. Selection of SOC, why we choose the Broadcom SOC for mobile segment because its power consumption, uh, the number of ports available, and other details as basically we need to interface the bigger TV, then HDMI is available, and the OS support is good. So we are, that is the reason, and more powerful as compared to other SOCs. That's the reason why we chosen for Broadcom SOC with the Raspberry Pi. Otherwise, we have worked with the other boards as well and build the smartphone. Yes. So what we wanted to express with this class is this. You have various options available to work with SOCs. You can choose SOC could be for initially to start with the SOC can be a Broadcom, SOC can be an Intel, SOC can be Qualcomm. But you can build the smart devices with any of these because we have done from all of this, whichever we have shown to you not worked on Qualcomm SOCs recently. There we have enough number of phones. We have almost 100 phones of various varieties from it's all sponsored by Microsoft and Intel on various platforms, including Windows phones to Android and Symbian, wide variety. Anything that need to work on this Qualcomm, we take the phone itself and we try to work. Otherwise, the boards which we need to buy, it is little expensive. It's costly. One costs about 50 to 1 lakh rupees. So hardly there is no requirement. But we do work with the for TI roadmap architecture. We have a couple of boards and which we do with and we can port. The beauty of this is, and some of the classes the students have asked me one of the important question which we still working on it, but we witnessed it that's happening. Like in laptops and desktops, you can port any operating system. Am I right? At least not but most of the operating systems. You may not able to port in this computer Apple OS. Okay? But you can port at least Windows, I can port or Linux or Unix. Just these three variants I can do that. But can I port, if I take my, let's say this is a Windows phone, can I port the Android in it? Can I put the Android like the way we seamlessly put the OS into the desktop processors? One of the other difference I must say, at present at least, you can put any OS to the desktop, but we cannot do it in mobile. Why so? Uh, because of the hardware and the OS feature that is embedded, it doesn't allow you to do so. But in general, I take, if I, for example, Raspberry Pi, I take an SOC. Pi 1, we did it, we show you if time permits. In Pi 1, we have ported the Linux and we also ported the Android. But we have a board on SOC of Qualcomm, sorry, TI OMAP code ported. It's not me, rather the TI has done it, but we have tested and experienced and shown, demonstrated you can it was 2011 or 12 I guess we called the TI people and they have demonstrated we were that is the first day enlighten us how the hardware and the software dependency is and how the manufacturers really play into that. The actual SOC brought from TI uh, has supported 8 different operating systems. What is just in the board, you just like to have a OS in the hard disk, you connect the hard disk, without the OS, it boots it. Am I right? It's hardly you replace the OS, so the hard disk, and you connect to any other hard disk which has a different and boot it, you get a new computer or a different operating system. As same as that, Boot that device with the SD card containing the OS Symbian. It acts as a Symbian phone. And immediately replace that SD card, connect with the other SD card which has an Android OS. The same device works as an Android phone. Now replace that and then connect it with the this another operating system. Linux operating system works as a Linux PC or Linux OS. Assume that the Broadcom, sorry, the TI OMAP SoC supports approximately 10 different operating systems. Same hardware, nothing has been changed. Only change is replacing an SD card with another SD card having a new OS. The same thing you could see with Raspberry Pi. Pi, not Pi 2, it would not work yet more. But in Pi 1, it supports 2 to at least 4 or 5 different operating systems. Most of them are the flavors of Linux only. But if you work, you can support it. Now, why is it not true? The same SoC I am using in a N900 SoC, N900 which uses the Nokia's mobile phone of those days, it has OMAP 4 SoC, but it only supports Linux, it won't support. There comes the word OEMs comes into the picture. The OEMs make a layer in between where no other OS you can use. Whereas the desktops, that is not the case. They allow you to do so. If the OEMs would like to use the same phone for any other different phone, it is quite possible, but that layer is being given and as a programmers that is hidden, that access is not given to port a new operating system. But here and there is a way how you can port, but that may not work every peripheral. But if you really want critically to do so, it is quite possible. You can work, but when the manufacturer made it, why I want to make my device some other people name because it's proprietary. I'm selling it. Because of that reason, all the services over there is my proprietary. My tool is supporting it, and if you do so, you can port seamlessly same device, any other operating system, because of the OEMs which they don't want to do so, we are unable to port it. And the JTAG port, most of the devices is hidden. Give it to you to test any debugging applications. Now, some of the problems may in future you will see this, the same device works with multiple operating systems. The way we could see, I want today smartphone as an Android, I want the same phone as a BlackBerry or so with the hardware seamlessly support it. Who are not allowing us to support it? OEMs, which takes the licensing from the SOC and they put their code, which never allows any other operating system to code. That has a found. So because of that, we won't be able to do. Otherwise, we won't be able to see. So some of the references are here. All the slides have been kept in my slides yesterday and today's slides. After the break, you can share it in the common email ID or you can copy it. Maybe after a couple of days, you can just copy or every day you can copy as per your convenience. And then I think a few, any questions before I talk about few things? Have any questions? Yes, please. I think this is not the right question to ask because there are 90 nanometers still available, 45 nanometers are available. Capacity of the designs. Today at present, Qualcomm the SoC of Quark, which as per my knowledge is the lowest as a product is available. I know it really you find there may be some SoCs lower than that. But higher versions you have 90 nanometers more than that size technology. That's the products. everything. So, but the research side, if you long, they were talking about electron size as a single processor, but that is not actually a reality. But anything that actually comes from development to a product, say that why so much one technology change to another, focus on it, how to have very that's the reason why we are still arguing. Just wanted to say in one of this couple of months back, I know the US standard invited by the Intel. I could see this Intel as a fab there. They had 5,000 employees working in fab, well as a manufacturing fab. Entire fab is by is sophistication. Assume that that much scale down to technology at one hand, but other hand, so many more in creating IoT applications, because it's primarily controlled monitoring and delivery, then security, safety, all those things. So what are we doing is we're trying to utilize the productivity more and more, but for that to do technologies on the other hand, people are thinking one or other way, cut down at one side, but they're created an opportunity in other side. Manufacturing process, let's say, cut down the shop on one hand, but how are you going to create that kind of automation in the next? One side is cut, so there is a balance always, right? So the answer that is various manufacturing technologies, fabs. So this is a process. The fab should have a facility support that kind of technology. Okay, and the tools, media tools also should have support to design such a technology and need the tools to do such a design technology to verify also. So it's entirely a production process. So as far as the actual product, I feel it Quark SoC still is the highest or lowest side strong technology which is made available. And you could see in Galileo Gen 2 boards, you have a Quark SoC small in size. Yeah, please.
So in microcontrollers, we see analog blocks being fabricated on the same kind of analog building blocks being fabricated on processor. If yes, they make it
No, they don't. The analog things are not on the processor. Rather, it is away on the processor in the SoC design. If you see here, there are the analog processors, analog signal processors, but they are not within the processor, rather away from the processor because of the power and other constraints. There is a placement of the components. There is uh, design issue. How am I going to place those components such a way that I should get the minimal copper consumption, at the same time electrical conductivity should be minimized and the power dissipation should be spread. If I keep two power hungry components at one place, your entire SoC will burn. So I need to dissipate and any more such a power hungry component they put it down the surroundings, not at one particular place. This is placement of components comes into the picture. There are in most of the SoCs there are power hungry components, but they take care of having some kind of materials that use power resistance. And that's the reason why initially the chips cost more. And when you go for low, nanometers technology, then the power consumption also goes down. More questions, please. Okay, it's fine. Then I think there are a few announcements I want to make it. The one thing, please verify your address and the name. I think they are trying to print for the certificates. And second thing, after the morning break, we will have a short session on design of mobile devices. Along with that, at the end of that, we will show you a working model of the smart device, the one which we have, mobile smartphone. Thereafter, the lunch break, and at that time, we distribute you the kit based on the certain process which we adopted. So we adopted a process. If there are people from three or four from one institute, we try to give one or two kits for the institute, and if the people from coming from the other institutions, two people from one station, one kit. But however, the kit has two books. You can work on this. When we give you the kit, we give you an indemnation letter, which you will be submitting at right now. But the same copy you need to fill it and submit it by your HOD or your principal later by mail to us. So this is required for as our records for further. And any update or anything we record and a new version we release it, we will be in touch with you people and even support you further. Or you can support for the same community. Let's say you developed anything and you can share it by your name, we trying to produce it for common academic community. Nobody will make us, or nobody create a healthy or better research or better education, a quality education. We need to do it ourselves. Okay, so and nobody will come and do it unless we do it ourselves. Please make your hands together, um, support that, and create. And anything is good or bad, we don't know unless it is made. People has to say it's good or bad. Okay, so after the break, the session will be on design of a smartphone. We will show you certain aspects, and then we will give you the demo, and then we distribute you the kit on the process. So I request you to write the details, and this kit is mainly for research and education, no commercial, and no individual need. It is for the community, for your research of in the college, for the students, and you can share it to anybody in the environment, but it's not for any commercial. If you try to do so, then that violates the rules and regulations, and it will be. Please make use of your own purpose and the research purpose and education purpose. Absolutely, it is free, but not for commercial purpose. Okay, I'm sure that. Um, we have hands-on sessions after the demo. I think anything else you need to share. I think these are the two things I want like to share. And after the lunch, we start with on the device on the SOC. You will build your kernel. I think it will take a little time. We will take the kernel building at the last session. Those who are interested to build your own kernel from the source code you retain. Some people maybe just easy background. I don't want a kernel. We will already build the kernel. You can use that kernel in the sense the OS. So you can use that OS and you start working on that. And those who wants to learn how I would like to bring source code to a kernel, they can retain, and maybe session goes Mr. Sanjay, who is expert and who has done the kernel optimization from the Linux source code, taking around 3 GB of source code size and brought it to 1.5 GB, removing so many other components which is not required for this particular thing, and build it. At least it's not completely miniaturized, but still it is possible we are working out. But what for us, it is 1.5 GB of size, we could do it today, and we will show you how it is being done. And then we also start with Python introduction today, so that you can work on little more. I'm sure Python itself will be taught for weekdays, so we won't be covering in detail, but at least for the experiments, what we are going to do, okay? So you can able to manage to do so. And otherwise, I already expressed yesterday, to start with small application development. Once you understand Python coding, you can build maybe let's say for some examples I'm saying it. Let's say we are interfacing the sensor, assuming that the sensor data is available, you can store it, and an average of sensor data you can display it as an SMS, or whenever the threshold reaches, you can dial a number. Small application. It doesn't require more than 20 lines of the code to really work out. Okay, so such a small applications you can think of and try to do, but we have a lot of exercises. And otherwise, let's say we interface the camera. Let's say take the write a program or write every, let's say at 12 o'clock in the night I need to take an image. Or I may be a researcher. I kept my device in, let's say, some extreme weather conditions, and I programmed this. It has to take the images as per my program, which I gave it, and transmit it to a server. At least you store it there, and you can schedule the camera to take an images. And during the night, then you need to change various modes. So you can set up the modes with how you can take an images. Similarly, if you interface with the Bluetooth, there's so many examples, exercises you can think of in that sense. Try to work on it. Okay. What's the time? You have any? 11. We have still some more time. Okay. Uh, 11:15. So what we do, I just quickly take up the other session. Then we will have a break, and then I'll demo it what we wanted to do and distribute the case. Okay. Sanjay, just
Design of the mobile devices.
try. I think we'll quickly go for try, then come back, not as per, then we will do this. Okay. 11:15 will back.
अभी इतना काफी कितने
विंडोज वाला बात आएगा कि हमारे जो इसमें ही चलता है, यहाँ पे विंडोज का कर्सर आ जाता है
वो अभी इसके अंदर आपको एक और एडिशन डालना होगा वो भी इसमें ऐड करना होगा
कहाँ पे आएगा
आपकी करवा दूंगा तो रेजोल्यूशन है कैसे लेगा
मैंने किया तो the laptop, the photos there. नेहा प्रेसिडेंट आपको अपने लिए करना तो बाद में कर लेना
करवा लिया मैडम इतना सही राजीव साहब से करवा लिया तो लिख गया कर दिया जो कर दिया है हाजिरा कहाँ लिखा है चाहिए तो स्पेलिंग इज करेक्ट जो ऑफिस कराएंगे उनके लिए चाहिए होगा गायब हो गया See, there are two attendance lists, right? One is you have to sign in the reception, where they have some attendance list there, and you have to sign it for that list. This list is required for ready software. You can issue it, right? Okay. So here there are only 25 people I am able to see. Whereas participants are around 34. If you see that इसका नाम नहीं है, right? आप लिख लीजिए, because it will help for them also. Attendance is required. You know why? Because this is a government institution. It's supposed to be transparent. It's functioning. अब attendance नहीं mark किया, right? That means you have not come here. That is one guess. Other thing is you have come here, but you have not marked the attendance. Now somebody puts RTA query, right? ये सरदार जी का नाम क्या है? जो आज आया, गुरजिंदर सिंह. तब गवर्नमेंट इंस्टीट्यूशन से आया, गुरजिंदर सिंह कितने दिन कोर्स अटेंड किया? अब मैं इमीडिएट डॉक्यूमेंट रिलीज अटेंडेंस की है, अटेंडेंस गुरजिंदर का नाम ही नहीं है इसमें. हमने सर्टिफिकेट भी दिया इसको 5 दिन का. सर्टिफिकेट कहता है 5 दिन इधर था, पर अटेंडेंस तो गायब. मेरे लिए पनिशमेंट एक कोर्स करने का एक राइट, मेरा एक इंक्रीमेंट काट दिया जो पनिशमेंट है, कोर्स कोऑर्डिनेटर ऐसे ढीला डाला है, जिसने कोई चेक ही नहीं करता, सबको सर्टिफिकेट दे दिया। एक इंक्रीमेंट को इनको सरदार जी की वजह से मेरा इंक्रीमेंट कट गया, राइट, मेरे रिकॉर्ड में रह गया, राइट, मेरा पर्सनल फाइल भी तो हो गई, उसमें लिख दिया ही इज वेरी डिसिप्लिन पर्सन है, कोई टेक केयर नहीं करता है, इट शुड बी पनिश्ड, कटिंग वन इंक्रीमेंट। ये पूरा जिंदगी भर तक मेरा पर्सनल फाइल में रहेगा, जहां भी जाएंगे, कोई भी इंटरव्यू में जाएंगे, फाइल खुलेगा। ओह यू आर सो लाइक दिस, ओके, ये तो सर, इसलिए आपने क्या करना है, जो प्रोसीजर मैंने बताया सिंपल सा प्रोसीजर है, ऑल आर टीचर्स कैन अंडरस्टैंड बेटर। आते हुए पहले रिसेप्शन में वो रजिस्टर होगा, रिसेप्शन में पर्सन है, ही कम्स बाय 8 o'clock, राइट, 8 o'clock you will come, 8 o'clock lab is also open, you can start signing, ठीक है। एक रेड्डी साहब के लिए भी who take the responsibility for this sheet, इस sheet के लिए कौन responsibility लेंगे, टर्मिनल शीट जो घूम रहा है, एक के लिए तो मैंने इनको लगा दिया था, एक के लिए आपको responsibility ले लेता है, उनका responsibility है सबको साइन करवाना, who will volunteer, Jinder Singh will do that attendance list for रेड्डी साहब के लिए। इधर जो मैडम थी क्या नाम था इनका, अनु, अनु will help for the tea breaks and the lunch break के लिए हेल्प करेगी। उसके बाद पार्टिसिपेंट को टाइम के बारे में बताना था, बात बताई थी आनंद ने, हाँ, प्लीज बी हियर बाय 9:30, एक्चुअली वी आर सपोज स्टार्ट द क्लास बाय 9 o'clock, आवर ऑफिस स्टार्ट्स एट 9, क्लासेस आर सपोज स्टार्ट एट 9, ऑल टीचर्स हैं, थोड़ा सा रिलैक्स भी तो करना चाहिए, राइट, ज्यादा रिलैक्सेशन मींस यू आर नॉट डूइंग एनी वर्क, लेजी एक्चुअली, थोड़ा रिलैक्सेशन इज थोड़ा एक्साइटमेंट है यार, चलो ऑफिस ऐसा नहीं है, आज तो आराम से गया, नाश्ता खाया, हाँ, ना को घर में तंग किया, बीवी ने पूछा ही नहीं है ना नाश्ता क्या खाओगे, घर में रहेगी, अच्छा हो गया, पांडे जी से पूछना है क्या खाना है, सब खा लो, सब घर में मना करते थे बटर, आज बटर भी खाओ, मैडम तो ही नहीं रहा है, वापस जाएंगे थोड़ा मोटा हो गया, मैडम पूछेंगे नहीं प्रिपेयर